Now, properties of integrals. Properties of integrals basically says, okay, I'm going to have some region, right? And I'm going to go from A to C to B. Yeah, it's a little unusual. Actually, let's just change it to B to C to make it easy. From B to C. And this is region 1, and that's region 2. Well, does it matter? I can set up an integral to find region 1. I can set up an integral to find region 2. I can find the whole thing. So basically it's just saying that if I want the total area, oops, let me change colors. I want the total area, it's going to be the area for region 1 plus the area for region 2, which means it's going to be going from A to B for, let's call this f of x dx plus the integral from B to C of f of x dx. Is that the same thing as going from A to C f of x dx? So all it's saying is that you can add up all the areas. Okay? It just means you get to add them all up. No big deal. You can cut them up. Now, why would we need to know that? Because sometimes we're given information and we're not given the whole thing. We're given pieces and parts. What you need to know is that you can, if you're looking for, suppose we were looking for region 1 and we had the whole thing, but we didn't have region 1, we had region 2. Could we subtract region 2 from the whole thing and get region 1? Because the way information you get it, sometimes you have to know that you can add up the two pieces, you could subtract one piece from the whole thing and get the missing piece. Because sometimes we're given information and we have to subtract something out to get what we want. We're missing what we want and we've got to work with what we're given. That happens a lot. All right, in the, so one of the things you need to realize is that I almost messed up a minute ago. I almost said A to B and B to A. Does direction matter on this? Yeah, because when you go from A to B, you are accumulating. Because if you were suppose this is velocity, I'm going to the right. My distance is going to the right. If I turn and go to the left, am I backtracking? So direction matters on this. So we're accumulating when we go from A to B. When we go from B to A, we're decreasing. Our amount that we have is decreasing of whatever it is we're accumulating. So direction matters. That means that another property is that if I integrate from A to B of f of x dx, it is equal to the negative of the integral from B to A of f of x dx. So what that's saying is if I went from, say, time of 1 to time 10, the distance I travel with that function to the right, if I turn on and go to the left, it's exactly opposite. It's the same amount, right? But I'm going to the left, so I just went back to where I started. So we're talking about the total distance would be double, but my displacement would be 0. That's what it's trying to tell you. Direction matters. The other thing is, if I don't go anywhere, or in no time, this is another property, if time is not changing, have I accumulated any area? Okay, that was really messy. I'm still learning to use this one. Integral from A to A of f of x. If time hasn't changed, have I accumulated anything? No. Have I got any area? No, it is 0. You can also use that property. Okay, we're going to record another one. Yeah. Okay. Oh.